and welcome to the Perl Maven meeting in the Code Mavens channel. This is part of the big Code Mavens channel. My name is Gabor Sabo. I used to teach a lot of Perl these days. I have a lot less work in Perl, so I do teach Python and Rust these days, but I still run the Perl Weekly and I still like Perl. So here and there, I try to give presentations also about Perl. And as I wrote earlier in the Perl Weekly as well, I would be happy to have other people, guests, speakers, who would present something in these meetings. This time in this meeting, I'll try to get a little bit get out a little bit of information about GitLab, and more specifically how to write pipelines or how to use CI in GitLab. I'm going to share the screen now. Hopefully, the right screen. And you're supposed to see my slides now. Right, which are not very pretty, but useful. And they are generated with various programs. Okay, so we're going to, I'll have some slides and I also will demo a lot of things during this presentation. And feel free to all those people who are in the meeting. So thank you very much for coming to the meeting. It's way better for me to speak when I see that there are people, and especially if they are giving some feedback. That's much easier than just speaking into the camera. So what I'm going to do now is I'll go over some of the slides and then show a couple of examples. Let's actually show something different first. There is this website called cpan Rocks that gives you some statistics about cpan libraries, modules, whatever packages, whatever you would like to call them. And one of the things that actually something is missing from here, but partially is there. So we can see on the right-hand side what version control system each module uses. So as you know, when you package something and upload to POS and to cpan, then inside you can tell where is the repository. Yeah, thank you for sharing. I'll share just remind me and then I can share the links as well. This is the cpan Rocks, and thank you, Andrew, for sharing it. So this is not my website, it's cpan Rocks. Actually, I don't know who is running it. Anyway, the thing is that you can see here what version control each one of them uses. Unfortunately, it only says Git. It doesn't say if it's GitHub or GitLab or something else. On the other hand, here on the left-hand side, there is this part where you can see the bug tracking system that can be also included in the meta files of a cpan package. And here we can actually see which one has a bug tracker on GitLab. So obviously there can be more there can be more. I mean, you can see that there are only 64% doesn't even say what version control system they use. So there might be many others who just don't include that information in the meta tabs. Here too, about bug trackers, you can see the 62% doesn't say, and you can see that there are 101 cpan modules that use GitLab, and probably for bug tracking, so probably also for version control. And we can look at few of them if any of them uses this the pipeline in order to run the tests. So Mark says that for version control system, Git is Git as Git, hopefully, regardless of central hub or lab. Right, yes, so the version control system is Git. I would really like to have a report saying which module uses which Git hosting service. I'll show you actually what I mean, because I do. I mean, I have the cpan digger, and it should this one, the cpan digger, that is collecting data about cpan modules, and I don't remember why the statistics is not there. Maybe I have never created it, or I just don't remember the link. I have a, sorry, Rust Digger. I have a similar project for Rust, and here you have I already have this. It's newer, so maybe I added some features here that I didn't have back in the days when I wrote the CPAN digger. Here you can see detailed information about which crate in that case uses which repository, and you can even see, I think, yeah, so you can see, for example, those who use GitLab directly, so they are using the hosting of GitLab, and then there are others that using GitLab installed on their own server. Okay, so here is the platform, and then ones. Now, why is it interesting for me and for purpose of this actually this video? The reason is because we can go to these projects and see how they use GitHub pipelines in order to run their CI jobs. So it's not that there's not other consideration here, I think, that just that we can look at other projects, how they use it. And actually, if I go back, so I'll just link this one as well. Yeah, in case you're interested. Anyway, if we are already, I wanted to show it later, but now that I sort of got into this, you can see here now we are looking at the Perl Maven website that you might be familiar with, and then in the archive I could find GitLab. I was looking for this because I wasn't sure, and sort of I remember that I wrote about it. So I found two articles, this one and this one. I'm going to open them. I'll put the links here as well in the chat. Okay, because apparently a while ago I wrote an article on how to create a pipeline for these the DVD mock module, but also I created a list of, back then there were 29 CPAN modules using GitLab according to the CPAN rocks. And now, as you might remember, there's 101. And this was the list of the ones that actually had GitLab pipeline. So we can actually take a look at now if they are still the case, at least for RX Perl. So RX, and then we get to Meta CPAN, and here we have the link to the repository, which is still GitLab. And you can see there is this gitlab-ci.yaml, which is the configuration file for GitLab. I'm thinking of moving my project to Codeberg or another how do you say it? Forgejo or Forgetjo? I don't know. It's Spanish or not. Host. Any interest in updating your diggers to track projects using its CI? There is interest. I don't know how much time I have if you're talking about the CPAN digger. I was even thinking of rewriting it in Rust, so it's might be easier for me to maintain, because now I have like 4 different versions of these diggers. Each one is in own language: the Perl, Ruby, the Python, and the Rust digger, and each one it's in own language, which was originally the consideration, so that people can contribute to it in their native language, which not really happened. So maybe it would be easier for me to just maintain one thing, but we'll see. Anyway, look at the CPAN digger and try to help with that. So I leave this open, this RX Perl, because maybe we look at its configuration file to get some ideas. Okay, so that's the sort of examples and background in high 10,000 miles view or whatever it says that. The thing is, so what is this thing? So first of all, GitLab, I assume that those people who are here, they know what GitLab is, but in case someone is watching the video and doesn't know, so GitLab is basically a platform, an open source, mostly open source platform that provides similar services to what GitHub provides. It's open source, so you can download it, install it, and there are certain extensions, I think, that you have to pay for and get a license for. But basically, you run your own GitLab service on your own public computer or on your private computer, and I think that's how they make money, that they sell this license or provide services to companies. So I saw a number of clients that they use the GitLab in their own installation, their own private installation. And the pipelines, so if you are familiar with GitHub, there is the GitHub Actions. Yeah, Mark says that his previous employer used self-hosted GitLab. It's always good that some people actually know the right words, that's self-hosted, which I just forgot, so I didn't say, but that's the right word. Thank you. So the thing is that just as with there used to be this Travis CI that is still around maybe, but stopped serving open source projects that allowed people to write some configuration files and run CI jobs, continuous integration jobs. In GitHub, there are the GitHub Actions that provide the same feature. And then GitLab, there's what we call the GitLab pipelines. And that's the main focus of this presentation, to see how can we configure a CI job. So let's get to the slides. Maybe I have some things here that I forget otherwise. So first of all, what is GitLab.org? That's the open source project. The complete DevOps platform, all kinds of things. So they provide all kinds of things that allow you as a company to work. That's GitLab. GitLab.com, get GitLab.org sort of. It actually redirects to GitLab.com these days, I think. But GitLab.com is the hosted version of this open source project where you can have an account and host your GitLab repository, Git repository there. And then they include many services like issues, they call them merge requests instead of pull requests, similar idea, what you have in GitHub. And they also provide these what they call pipelines that you can do some configuration, and then on every event, let's say on every time you push out some code, they will fire up some virtual machine. Inside there, they fire up probably a Docker container, and in there, they will execute the code that you tell them to execute. And probably the most common thing to do with this is to run your compilation, if your language needs compilation, and run your unit tests or integration tests or whatever you need. And then people can go on with this and even deploy their code. Or if you are writing an open source CPAN module, then you might configure it to upload to POS and eventually to CPAN your library once it passed all the tests, let's say. Okay, so you could do that. I never actually did that part, the CI, the CD part of this, so releasing to CPAN. But it's okay. This is just an advertisement for someone who is running the local. Actually, it's not just local. He's running also globally. This company provides all kind of the service around all kind of open source technologies, including GitLab. So in case you need professional support, then maybe that's where you go. And then if you go there, please tell him to give me whatever percentages. Anyway, he's nice to me usually, so it's okay. So CI, continuous integration. The idea there is that you have hopefully some tests in your code base, and then you would like to make sure that every time you or someone else makes a change in the code base, then all these tests are running. Now, again, if your language is also compiled, then you need to compile it. And back in the good old days, we had the nightly builds, So once a day or once a night, actually, everything was built, and then by the next morning, you'll find out that you forgot a semicolon somewhere and the compilation failed. The idea because behind continuous integration is that it happens all the time, continuously, so on every push. And then if you work like I do, that you do very frequent small changes and small commits, and then you frequently push that out to whatever cloud service you have, then you will have a very fast feedback loop. So we'll find out about any issues you might cause, you or your coworkers cause, very fast. Now, when you are more than one people, then the integration part is that if someone makes a change and you make a change, and even though they may maybe both changes in themselves by themselves are good and correct, but once you combine them, they fail. Now, continuous integration will integrate these things and find out the problem much faster than if you were waiting for the nightly build. Okay, so this is sort of the theory part of this, and my button stopped functioning. Yeah, okay, now it moved. Some links to the documentation in case you're interested. So there are quite a lot of documentation. Actually, one of the nice things about GitLab is that one of the few companies that they were originally distributed. So they didn't have any offices. I don't know if they have now something somewhere. Maybe they bought a company. I don't know. But last time I read about them is that they were totally distributed in some 60 or 70 countries. They had employees, and everyone was working from home or some office they rented or whatever. And so they document a lot. Okay, that's the sort of the connection that that's why their documentation, that's probably part of the reason why their documentation is good, because they know that their real way to communicate between all these people is writing down whatever needs to be communicated, because they are in different time zones, they work at different hours, whatever. Specifically, there is a link to the documentation of GitHub pipelines as well. Actually, let's go there. Hi, yeah, okay. Let's open this one. So I'm not sure, and there's lots of words here, okay? Yeah, it's difficult to, as Mark says, it's difficult to maintain a self-hosted version of GitLab. Yeah, I didn't have the luck or the whatever or the bad luck of maintaining actually one, so I don't know, but yeah. Okay, so runners. When you configure a job, sorry, when you write such configuration file, and let me actually, where is my terminal? Okay, so here is my terminal. We are inside the repository of one of these, a project on GitLab that I created specifically for this presentation, and I guess I'll keep it around. So I'm going to show you right away what's going on. I comment out the rest of the things here. So what we have now is we have this GitLab. I show you again this file called .gitlab-ci YAML file. And inside we have lots of commands, but what we have here is this default colon and then indented script and some command. So basically we are saying that there is a job which we called default. This is an arbitrary name here. And that job runs this echo hello world. Now I git add and git commit start. Okay, I don't have much to say. And git push out. But before I push out, let me find this repository. So this is the repository. I made some changes earlier today. And in this repository, you will see that on the left-hand side and each repository, there are the pipelines, and inside there are the jobs. So I go to the pipelines to see what's going to happen. So there are lots of failed things. We'll get to there why they are failed, but that's the example. But now I'm going to push out. And as I pushed out, I can come back and hopefully it will automatically update itself, this page. Maybe I reload it. I help it by reloading it. Okay. Yes. Okay. So maybe it would update automatically. I'm not sure. I used to remember that it does, but whoever. Okay, whatever. So it now says that there is this pipeline which is running. This is the commit message. This is the, I guess, the ID of this pipeline job thing. David says that the workspaces are the coolest thing in them. Okay, but we're not talking about workspaces right now. Anyway, so it just says that this thing passed. I can click on this one, and yeah, so it refreshes automatically. Victor says, yeah, okay. So I clicked on the pipeline. Here inside you can see the jobs. And so this is the job, and you can see the output of this job, and you can see it printed out hello world. So what happens is that, and I get back to the runners. So when I push out something, or there might be other events, like maybe I can do manually, or I can call some API and run this, or I can schedule something. So there are various events, but once that event happens, then GitLab picks up this file, reads it, and executes whatever is written in there. Now, in this one, we only had only had a job which called default, which has a single command, echo hello world. So what it does, it starts up a virtual machine called GitLab runner. So it calls a runner, which is in this case, I'm trying to look for the information. I think this is the ID of this, or the tag of this runner. I don't see what is the exactly, I guess this is a Linux runner. Here it says it's a Linux runner. Okay. And then inside it starts a virtual machine, sorry, a Docker image, Docker container. And by default, it runs this Ruby 3.1 Docker image. And then inside that image, it executes your script. And of course, there are lots of other things to do, but it executes the script. One of the things is that it clones the repository or somewhere. I checking out, okay, detached head, whatever. So it gets that specific commit, and then here it executed the command that was in that configuration file. So that's it basically, that we are done. Someone is writing again within GitHub. You need to find some way to somehow organize the projects, ending up putting custom attributes. Not cool in my opinion. Okay. Are you sure how Docker image updates automatically? It depends on your setup. Okay, I don't think that the update was meant about the Docker. Oh, I closed it. Sorry. Wait a second. I have to open again. Chat. Okay, I close the chat. Okay, I don't know if the Docker image, so I don't know if the automatic update was related to that. It was about, I think, the view of the list of jobs or pipelines running. Anyway, so back to this point, we have these runners, which is the virtual machine, I guess, or hardware or whatever, where you are running, where these jobs can run. And then you can, the jobs are usually actually running inside a container. It's not always, but it's usually they are running inside a Docker container. So, and so you have a full control of which container, it keeps opening the reply window. Anyway, which container you would like to pick. We'll see that soon. So the runner is actually, there is an operating system that can run on a virtual machine somewhere you rented. there's an agent on it, and then GitLab is talking to that agent. And by default, and let me get you to this point, by default, if you scroll down here, settings, so I'm in the project, I scroll down to the settings, CI/CD, and then there are the runners here. By default, there are lots of runners that GitLab provides. If you don't say what runner to use, then it will use the default one, the one that we saw now, I guess. Okay, I don't know if maybe it's picking one, so it's picking something small and cheap, I guess, relatively. You can also use these tags to say that you would like to use some other runner. So that by default, it's a small Linux machine, but you can also get a Mac OS, you can get Windows machines in order to run on them. And then, of course, you probably are interested not using a Docker image inside, but running natively on that. And in addition to these runners, you can actually configure your own runner. So at quite a few of my clients, what we had is that we were using GitLab.com, so the hosted service of GitLab, but we started our own machine. I don't know, in Google Cloud or Amazon Cloud, doesn't really matter. So we set up our own machine, configured it to be a GitLab runner. It was included in here, so you could see here in this project runners, we connected them, and then we could use in our jobs, in this configuration, to tell them to run on these specific machines. And that's good because then our code doesn't go to these shared machines. Well, these are still shared, but less so, I guess. And you might have some things that you configure up front. You might store some data there that you need to have for your projects and so on. And theoretically, you can even have that runner inside your office. So at one company, though that wasn't GitLab actually, but doesn't really matter, what we had is that we had a machine and a computer, and to it we connected all kinds of interesting devices that were rather unique, and we had to run the tests on these devices. So GitLab was telling this runner to run the code, run the job, and that runner had these devices connected to it, so it could run the jobs actually on those devices. So it's pretty cool because then you're still using the cloud-based GitLab service, but you're totally in control of your runner. And obviously, it can also have price impacts on price of if you have a runner constantly up, that has some cost. If on the other hand you are using theirs, then you probably have to pay at one point if you'd like to have more time spent on their runners and so on. So these are the runners. On top of these runners, especially on top of the Linux runners, you're going to probably use a Docker image. You saw that the default is Ruby something, 3.1, if I remember correctly, but we'll see how to configure it. Wow, okay. I am talking about a lot of theory, and I haven't really showed you yet. Anyway, so we got to the point of the GitLab CI, just link to YAML. This is the configuration file. So here is the very first one that we actually saw already, that has some name, job name, and then inside there is the script. Strangely, or I don't know what, the word default is actually a totally arbitrary user-defined word. You can use anything there. The script is on the other hand is a required field that's what will be executed. Okay, so in the script you can put what to execute, and here there's just a shell command, but of course you can run anything there. So you could pick an image which is Perl something, and then you can run your Perl script there if that's what you are interested, or any other language if that's relevant. So we already saw the same thing in this example where we have this default and the script. Let's go on and see a couple of more examples. So the next example, actually, before I show the next example, let me get here. I'm going to comment this out. And I'll show you this. So I organize these examples so I won't have to comment out way too many lines, and we can have each file separately. So GitLab allows this configuration to include other YAML files, both locally and from other repositories. Here, in this case, I show them locally. So I have these files in CI. I just called a folder called CI. And then I have this hello world YAML file. And I should open it this way. Okay, so this is basically the same, except the string is slightly different. And the point here was to show that you can include them. Now I'm going to skip this because I hope that you trust that I can do this. And so I'm going to switch to the next example. So in this one, you can see that the only change basically is that I set up, I configured the image. And so I can now git add and git CI image, and I push it out. Okay, so let's go back to the not this page, not this page, but not here, to the build pipeline. So here I could go directly to the actual jobs. So each pipeline is divided or can be divided in separate jobs. Right now we only have one job, so it doesn't really matter. But I can go to the pipelines, and then inside the pipelines, you will see the jobs. So here I have one single job. If I scroll down, here you can see there were several things running. Actually, these are stages, so let's not confuse. We'll see them, the difference between them. So here we have this, and this one, the commit image. If I click on this one, then I will be able to see, the output. But which is most interesting to me is seeing the image right here. So it says that it's running on BusyBox latest, which is just a very small Docker container. Okay, of course, you can pick anything there. Let's go here. So hub, Docker. Okay, so I guess you're familiar with this. You can pick any Docker container, and then this basically will, you don't really need to understand what to do with the Docker container. You just write the commands, and it will just run inside the Docker. So let's say if I go for Perl, then there are various of these Docker containers, but you can say, let's say, Perl 5.40.0, and then it will pick that specific Docker container that has this version of Perl already installed and compiled, already installed in it. And you can get all kind of different ones. Okay, so it's really, and these are pure Perl things, I guess. And then there are others, the Perl test image and all kind of other images that already contain lots of modules. So your whole job will be running much faster because you don't have to install all those things yourself every time you run your code. If anyone can remembers the Perl test, what was this? Perl, I think it's called test. Anyone remembers? Perl, maybe is this one? I don't remember. No, it doesn't look like the one. Anyway, if anyone remembers which is the Docker image, what other Docker images there are suggested now these days, let me know please in the chat, and then I can share it also. We can look at it. Okay, so this is how we pick up the container. Now this one, maybe I won't even, I can run this. This example shows that I can run in the script several commands, not just one. So if I go back to this one, I can enable, disable. So I have these run shell commands. it will do this, git add, git CI add. I'm not very good at writing these commit messages this time. Not that in other times I am, but anyway. So, okay, I'm going to close this window because I don't need it. I can click now on the jobs, and then I can see the new job, which is called add, which was called add. It doesn't say here. I guess, yeah, I guess this is the output. So here you can see the output of all those shell commands, showing all the environment variables that you have there, the uname, so you can see exactly what type of things you have. Not that it can be useful for debugging later on. Okay, now next thing. So here what you can see is we have actually 3 different jobs. And in each job, there is a stage. Now, earlier, you might have noticed, let's see if it says, exiting stage. Yeah, it says here, it says actually that the CIC job stage is called test. I think also outside you could see that the stage is called test. So there are various stages of your process of your CI job that your CI job can go through various stages, and the default one is called test. And in this configuration, and I'll just get to the point of Scott in a second. In this configuration, what we have is that we have these jobs, separate jobs, and each one I put in a different stage. Now, I'm probably not, it wasn't a good idea to do both of these things at the same example. So I probably should have done only just set the stages. But anyway, they, yes. Okay, so while it's running, let me look at the command. This may be covered eventually, but what's the best method for syncing the CPAN modules on a development machine to a Docker image? Sorry, method for syncing the CPAN modules on a develop. Okay, goodbye, whoever is leaving, David. Okay. I'm not sure I understand your question, Scott. So you probably have. I mean, you can have. So there is the default way of telling your. Okay, so the question is what is the best method to syncing the CPAN modules on a development machine to a Docker image? I mean, if every time I wrote any project in Perl, even if it wasn't for CPAN, it had a makefile PL or whatever you manage, or a CPAN file, where I said which versions of the modules I needed. I wasn't very strict in these, unfortunately, back in those days in Perl, but you can actually really fix the versions in the CPAN file, if I'm not mistaken. And then it will pull those specific versions whenever you need it. And you verify that those are the versions. And then you'll have to maintain these versions and upgrade them as those modules are advancing and as you need to upgrade them. Carton, Camel, someone wrote, that's the tool, yeah. Carmel, sorry, Carton and Carmel, okay. I mean, building up a Docker image that includes the CPAN modules on a development machine, like how to layer the image and export the installed modules. Yeah, I don't think that I'm going to get into the how to build a Docker image here. But I think I'm doing the same thing. So if you really want to be strict, then go with Carton. I don't know Carmel, but Carton I do. So these tools that were mentioned in the chat, go with them. They will allow you to exactly say what version you need, and then that's how you use the standard Perl tools to install them into your Docker image. But okay, so Carmel is the same as the updated version of Carton. Okay, thank you. Okay, sorry. I'll get to back. So we are here, and it was upgraded to. Where is the commit message? There's no commit message here because we are in the jobs. Okay, I hope that this is the right one that I wanted to look at. Actually, no, 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 no. Go to the pipelines, Gabor. That's what I wanted to show you. The pipelines. So yes, this was the last commit and push that I made, where you had 3 jobs, each one is in a different stage. So if I put the mouse here, you can actually see this is the build stage, this is the test stage, and this is the deploy stage. Now, these are just names. You can do whatever you like in them, but they help you to get the idea what you're supposed to do in each stage. They are also dependent on each other. So, and then they will go off one after the other. So now if I click on the pipeline itself, here you can see the drawing clearer, and then you can get into each one of them and see the detailed output of each one of them. And they are dependent on each other. So if the build fails, let's say, then the test won't run. And build, test, deploy, that might be a good naming convention for a more compiled language, but even inside Perl, you might separate some part of the commands into the build phase and some, let's say in the build phase, you put in all the, I thought about putting all the prerequisites, but no. So maybe, okay, so here's an example. You might do in the build phase, you actually run the unit tests, create your image, create your CPAN module, upload it somewhere as an artifact, and in the test phase, you use it as an already created and zipped thing. So there you are actually, you CPAN install your own, the new release of your own module before, not before even you upload it to CPAN. So this way, and actually I have somewhere, but I think I did it for GitLab, the same idea. I didn't do it for, so I did it for GitHub, not for GitLab. So in the build phase, I was running the Perl, the make test and the make dist. It created a zip file. That zip file, I stored it under the artifacts of GitHub in that case, but also in GitLab. It stores it somewhere in its cloud. And in the test, I would have several jobs on different versions of Perl, maybe even on different operating systems. And they would download that zip file, which is your module. And even if you're running it inside, if you're doing it in a company and it's not public, that's fine. You can still package everything up as if it was a CPAN module, and then install that and run the test of that. And it will pull in supposed to pull in all the dependencies. Okay, and then the deploy would, I don't know, maybe if everything worked fine, the deploy would, in this case, if it's a CPAN module, would push it out to CPAN, or if it's something that you want to deploy, then it would do the deploy. Okay, but that's just naming, just a default naming convention. So this is what we had here. What time is it? 15 already. So almost 3/4 of an hour I've been talking. Way too much. Okay. Manual stages. Okay, so we saw the default stages, but you might not like these build, test, deploy words. So you can define your own stage names. And so you have a keyword called stages. Then you list the names of the stages you like. Let's say prepare, lint, compile, unit test, integration test, acceptance test, deploy. okay, or whatever stages you would like to have. And then you can create jobs and associate each job with one of the stages. Or maybe you have several jobs associated with the same stage. So I won't run this now, I think. If I'm not mistaken, I already have it, the image here. And there is a slide I didn't cover, so I'll get back to it in a second. So define your stages, and then it will look like this. So it will have this one after the other. But I get back to the stage, to the slide. So you have the hierarchy of these words or names or entities. There's the pipeline. In the pipeline, there are stages, one after the other. In each stage, you might have multiple jobs for each stage that will run in parallel or can run in parallel. Each stage can have one or more jobs, okay? And even if you define the stages, you don't have to fill all the stages, okay? So it will, if there are stages that don't have any associated job, then okay, there's no. So, and this is the association. So for inside the job, you tell what stage it belongs to. And then there are the scripts. So each of these jobs have an entry called script, which runs something, okay? Next one, parallel jobs. Oh, good one. So this one, how does it look like? And I got back to the default naming. So here I have I called build job, is in the build stage. Then I have a test job, a unit test job, an integration test job, and an accept test job. And they are all in this test stage, meaning that they will run in parallel. Okay, now that might be a good idea, bad idea. It's up to you. What is the right hierarchy or order of these things? Because if you run them one after the other, it has the advantage that if the unit tests fail, you don't waste your resources on running the integration tests, let's say. On the other hand, it will the total time will be longer because this runs linearly. If they run in parallel, then maybe the unit test fails and you wasted some time and energy on running the acceptance test at the same time. But if everything passes, then the total time will be shorter. So that's up to you. You can also have different types of tests running in parallel. That can be also good. So you might divide your unit test into separate groups and then run them in parallel to make sure that again that they will run faster and you get the things done faster. So hopefully I have the slide already with that. I don't. Apparently I don't. Okay, I'm sort of mixing these things up a little bit. Anyway, so let's run this to see how it works. Okay, git add, wrong, git add, git ci-m parallel. I hope that I put the correct number of L's in that word in the right places. GitLab, let me just open this file. So now, if I go to the pipelines, it will show me that it's running three stages in this one. And right, so you can see that in the build, there is the build stage, it's running. And once the build stage is ready, then the three test stages that are in parallel, they all start to run. Now, I don't know what is the limit. I guess there is some limit definitely in the free version. I'm using the free version of GitLab. But I guess if you pay, then you can have more of these running at the same time. And I'm quite sure that there is some total time limit and whatnot. Recently I don't deal that much with it. So anyway, so then once you have, then you might have two different deploy jobs once the tests have passed. So that's how you can run things in parallel. What else? What is the next thing here? The next thing is manual interaction. Okay, so this is not the right one here in the slides. Yeah, so there is a slight mix-up between the slides and the order of the examples I have in the file, because the parallel jobs you can see here in the slides. So let's see the next one in the slides. It's called jobs. So here, what we have is that in each job, so far, we had an entry called, it's not, okay, that's not what okay. So in each job, forget about the slide for a second. Each job we had, let's see this one. For each job, we had a field called script with some comments. But you can also add the before script and then after script. And these are steps executed in the job, obviously before the script runs and after the script runs. And the interesting part, or the valuable part of it, or why would you want to separate, is because you probably put in the before script up all the setup. So think about it's the setup and the teardown of the job. So you probably put in the before script all the installation of the dependencies. So that's not your test. But if that fails, you don't want to run your test, because, but you would like to see, probably know separately that whether your before script part stopped, broke, or if your actual test, which is in the script part or the main thing. The after script is interesting because that will run even in this case when you see that the main script actually fails. So here on purpose, I wrote some Perl script that will exit with an exit code which is not 0, meaning that the CI job will see it as a failure. So git add, git CI fail. This CI thing is just an alias for me. GitLab. Keep forgetting that I need to stay in the editor. Pipelines. It was still blue because I don't know why it didn't update properly, but now you can see this runs, and we can wait a little bit. Now, in the meantime, let's yeah, okay. Okay, I'm getting to the almost an hour I've been talking, so soon I guess I'll have to finish. Even though I wanted really to see one of the examples. Let's in the meantime see so what's going on here. So just you can see the before script is cpan m with recommends no test minilla. Okay, whatever, installs minilla. And then it has various jobs, okay, for the test stage. And it says apparently it uses images, different versions of Perl. So this is that image that I was looking for earlier. So that I mentioned that there is a Perl image with all kind of modules already inside, specifically for testing. So this is what is being done here before the script. So just to be clear, is my explanation. Let's get back here. In this example, what we had, that we had a job called default, and inside the job we had a before script, a script, and an after script. In this case, outside of the jobs, there is a before script, which means that this will run before each one of the jobs. So basically, this before script is inherited by each one of the jobs. You could overwrite it, so you could have your own before script in one or more specific jobs. But if you want to have the same before script for every job, then this is what you do. Outside of it, you say this is the before script, and then you have these jobs. And in these jobs, you can see that they are all in the test stage, running on different versions of Perl, and it just runs minimal test on each one of them. And that's it. Okay, that's the whole story here. Okay, so it's not a very complex setup. It uses, but it's a nice one. Let's go to another one. This is the game entities. I have no idea what is this. Well, it looks a way more. Oh, okay. There are some interesting things here. So this is the job. It has some rules when to run. Okay, run always, but only if the condition is a merge request event. Okay, so by default, I think it only runs when you push out something. When you can say when and you can say always, and then you can have these if statements saying, oh, but only if the environment variable CI pipeline source is merge request event. So it only runs on merge request, this workflow. And then there's another condition, if the commit branch is the default branch of the project. Okay? And then each one has some variable set. And I guess later on, somewhere, maybe in the code base, you use these variable environment variables. This one allows you, this dot sum notation allows you to reduce duplication. So that's actually the nice thing. In this one, in the RX Perl, we saw that basically this is copy paste. Okay, so the only difference between this and this, well, is the name of the job and the name of the image. And so there are duplications here. This one solved this duplication by saying, okay, this is basically the job, and each one of them is using this one. Now, you could, or we could, does it have a, yes, lovely job name, okay? So the image is picked up by the name of the job. So you don't even have to have this duplication. In this case, you see, the name of the job had a Perl version, and then here we also have the Perl version. In this one, you only have the Perl version here, and then inside the job, which is this, basically this star test, I think, this says that use this thing as if it was there. So think about it as a function call or whatever. And then we are using this variable name to set the image. Very nice. Okay, so I have a lot less duplication, and if I want to add or remove a version of Perl, I just do it here and that's it. I don't need to update anything else. This one also has a, and I don't know why it's in quotes. Maybe coverage is also, I don't know why are why is this a quote. This one, I guess, because they are numbers, but okay. So this is the coverage job, which runs on this image before script does all these things, and the script is actually running the cover. And there somewhere, I don't have it now handy, but you can also, and I'm not sure about Perl, I used it in Python. You can have the coverage reporting tool print out something, and then the CI job in GitLab pick up the results of the cumulative or total results of the coverage job, and then it will show on the right hand side, I think, of the you can collect all the coverage report and have it uploaded, so you can then open it in a browser, the web page, and you can easily see what is the coverage report for each run. So you can do that. And obviously you can do what is not done. Yeah, it is actually done. It pushes out to coveralls, and then you can go to the coveralls service and look your coverage report there. This one. Any comments, questions? Okay, so this one has a globally defined image. Some globally defined variables. it uses caching, I guess. So it will save time on repeatedly installing the same thing. It installs some Linux packages, right? With apt-get update, apt-get install, this one. Fine. Then does all kind of commands. Okay, so these are the commands done before the actually testing, and it's done globally. Then this is the unit test job, which has variables. This is the script. And now, nice, this is the artifact. I mentioned you, right, that I can upload artifacts. So here they are uploading the JUnit artifacts. Let me try to see if we can get, I'll get to that later in a second. Test coverage. This one is the one. Okay, so I didn't even have to copy paste mine. So this module actually uses this. So if you run this coverage, run this testing with the coverage report, it will print on the screen something that says total blah, 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 okay, something. And then this key will probably, if I understand it correctly, get that line and report it on this website. And then the builds phase is just uploading the artifact. So it is quite similar to what I explained, that this uploads, it generates with Zilla, it generates the targ gzip and uploads it to the artifact library. So let's take a look at where these things are. If I go to the pipelines, well, it hasn't been built for a long time, it seems, so maybe all these things were cleared, but so this one passed 4 years ago, pretty long time. So maybe all the things were cleared since then. Yeah, I don't see any of the details. Artifacts are here. Yeah, these are the artifacts. So this is the released or to be released zip files. I don't see the coverage report here. Maybe that was removed or this thing was added later. I don't know. It would have been nice if we had time to actually implement one of these things. So, okay, this is not interesting anymore. Set stage of job. Okay, we see this, saw this, not interesting. Parallel jobs, we saw already. I won't show this anymore. Oh, actually, I will. I will. So let's get back to it. So we saw the before and after. We have the manual interaction, which looks like this. I have a build stage. Let me run this. Git add CI manual. Before I push it out, was I in the middle of something? This one. Yeah, this one I wanted to show you and I forgot. If you remember, this was the before after thing. Let me go back and show that before I go to the next example. So that was the before and after, where the interesting part was that the script itself failed. On purpose in this time, but failed. So this is how it looks like. It says the echo before, you can see it. There is the Perl thing that fails, and then the echo after, which also works. But the whole job fails because the main part failed, but the after part still runs. So if you need to do some cleanup or whatever, despite the fact that the test or the main part of the job failed, then you can do it. Okay, so let me push this out now, the changes. And this is the one that we wanted to see, the manual interaction. So here we have just build, just test, nothing special here. And then there is the deploy. And then the deploy, you say, okay, it runs manually. So it doesn't just run. And it will even look for an environment variable called name, which is not defined in this script. We'll have to provide it. So what happens? I go to the pipelines. It runs, okay? It went through the testing phase. It goes to the build. This was build. This was testing. And it's still testing. Let me click on this one now to see. It's still testing. Let's wait for a second. So when would you want to use this? If your regular thing, you would like to, okay, you want to have all the jobs to have the CI, but you don't want them to be automatically deployed. You would like to be able to manually decide which one to deploy. So now, you see that, oh, this was, maybe the deploy is going to be uploaded to cpan. Okay, so everything is done. Okay, you are happy. And now you would like to do the deploy. So you can either click here to run it, or you can click on the gear icon and provide some input. And so here we can provide the name field, and here you can provide foobar and run job. And now you run that job. And I don't have experience in how to set rights on this. But if you're alone in this project, or if you are, meaning that if you are the only owner of the project, unlike in the companies where you have multiple people, then it's easy because many people can push and you can also push, but it's only you who can type these things in. And you don't have to have that field, okay? I only used it so you can see that now you can see it prints it out. Because if we go back to the thing, that's what it does, okay? It just echoes the deploy. And you can see one more thing here that's totally unrelated. In this case, I had this pipeline, and then I had several shell commands. Earlier, I had this one. Okay, both are fine. If I'm not mistaken, the difference is that these run in separate commands. And if I have a pipeline, and like this, then it is being saved as a single file and then executed as all the commands as a single executable. So that's basically the difference. So this is to allow you to manually do something, but we can also have another one. Let's see, a more secretive one. Let's do this one. How does it look like? Very similar. Build stage, test stage, fine. And the same here, deploy manually. But this time I don't have the, no, not that I don't have. I have a constraint that's saying this script should only run if the user provided a variable name code that if you're running the SHA-256 on it, then you will get this SHA. So I guess, and the funny thing was that this I wrote a couple of years ago, and today I wanted to make sure that everything works, and well, not everything works, but it's okay. So far I've been talking more than an hour, so quite a few things work. And I didn't remember what was the actually word, the original word that created this SHA. But after like 10 experiments, I could figure it out. Wasn't that difficult. I have very few passwords. So if you go back to the pipeline, okay, now we are here. Okay, this push passed, and now I think I can click on this one and deploy manual action. And now I have to provide it. So I had to provide, I think it's caused, it's case sensitive. And here I provide now, this is unfortunate that I can see it in clear text, but this is the secret. It's very big secret. No, it's a small secret. Okay, the code was big. And so it's running, and then it will hopefully work. Now, if I go back to the slides, I think I put it there. Manual approval, yeah. So the way to generate this is basically this is the command on Linux. So you just run this command with your secret, and it will generate the SHA. And then you can save it with notice there is this spaces and dash here. That's part of it. So part of at least this output, I have no idea. Maybe I just made the wrong command. So this way, in the CI, you don't need to save a clear text version of your password or whatever secret. You can have a SHA version and then type it in this view. And it's unfortunate that you can't have a secret one, or maybe you can. I just don't know. Anyway. It succeeded. Okay, it actually printed out the secret because I asked it to do. You probably don't want to do that. I just wanted to verify it for myself here, and it verified this condition, and everything was fine. So the job went on. Okay, and I keep closing it editor. I don't know why. This was pick runner. Okay, so I showed you how that there's a list of runners. This is how you can pick the runner. Okay, you say tags, and then you give it the name or names of the tags that were there. If we go back, I think here in the configuration settings, CI/CD. Yes, the secret is secret in this case. It's a very secret. So these are the runners that are available. So you can put the tags. These are the tag. No, the blue ones are the tags. So you can put the blue ones there, and then it will pick the right thing. And then just notice that this Windows one, it's actually running natively on Windows. So your commands, and that was a little confusion for me. It actually runs very slow, way slow. It takes a lot more time to start such a virtual machine than starting the Linux ones. I don't know whether it's because they're not running up front or it just takes longer. I don't know. Anyway, so you can see here that I have two jobs, and one of them is running on Windows, another one on Mac OS. Not that interesting. I won't try to show it, especially because it didn't work last time I tried. There are some to-do items here that I wanted to show. Actually, this one, I can show you the explanation. Here, there was I copied it from some job at a client. What we had here is that we had to run sometimes a specific job manually to clean the runner, okay, remove all kind of files that were there, and instead of going SSH into the runner or own private runner, we had this job that would work, and it would work if the user provided a variable called clean runner with whatever value, which is not 0, so just clean a runner 1, or if any of these files changed. Okay, so we had a Docker file because it was Python, so we had a requirements and constraints file, and which is like the list of the requirements, list of the dependencies, and the pipeline itself. So in these cases, it should run, and then the rest is just doesn't really matter. Okay, so and it was running on our shell runner. So in our runner, we had one that was running inside a Docker, and two configurations, one that allowed us to run inside a container, and the other one that allowed us to run natively on our Linux box. And so this was called the shell runner. And so these commands were running on the native system. In this case, it's cleaning up all kind of things. The details are not that important, the details of the script. What is important that you have these conditions that you can use. And then this one, I guess I have to find the slides because I couldn't finish the preparations, but we don't even have the time for that either. This one is the link. So, and let me show it a little bit here with the documentation. So you can, if you have like just a plain Perl script that you want to test, nothing interesting. You can do whatever we did so far. You just run Perl, make file, make test, and so on. Regular things. But what if you need to run your, and maybe that's the, yes, the DBB mocking. Is it? No, I don't have a story. No, it's because it's mocking. Okay, I don't have anything interesting here, I think. No, this is not interesting. Not more interesting that we have already had earlier. So back to the stages. So maybe you need an actual PostgreSQL database in order to run your test because you're running the DBD PG, okay, which is actually on GitHub, and it has a, I think already the CI because I configured it, but whatever. Here, let's say you have some project that runs on Postgres, or there are a couple of other examples. It doesn't really matter what, anything that can run inside a Docker, okay? So you can configure, say, okay, default, this is the name of the job, and then that job has a service, which is called Postgres. So what will happen is that before running your job, or any there, before running this specific job, and before running your specific job, GitLab will start a separate machine, basically, so separate Docker container, run PostgreSQL, so this image. You will probably define some parameters, and then in your program, you will be able to access, using the name Postgres, that machine. Okay, so you will have an actual Postgres machine running next to your Perl code, and so we can access that. And you can do it. It has explanations for MySQL, PostgreSQL, Redis, but and I don't know, GitLab as a microservice. I have no idea what is this. I guess I haven't. Yeah, I'm not guessing really because we do use it in our at one of my clients. I just couldn't demo it here yet. I couldn't finish the demo. You can use anything. So we are using, for example, and I think here I had the beginning of it. I haven't finished the part. We have MongoDB. Okay, so it just says, okay, run this image. Okay, start it up. This is going to be the name of it, and then I don't have the rest of the code, which is our real job, that should access this MongoDB server. Okay, and so then you can use one or more real services, and if you have several services yourself, so not just these external ones, but your architecture is the microservice architecture, then you're testing one piece, but maybe the others are already available, should be available for you as a Docker image. And so you could just need to configure to be, so this thing will be able to download that image, which is another set of things, but we don't go in. And then it will download the images of all of your microservices, and then you're testing one of these services against all of the rest of the system. So this is just a demo of the demo. That's it, I think. Do I have anything interesting? So it's a little bit of work to get this done, to get it working, but it's doable. Yeah, the slide is empty. This I have already showed you in a different way, the before and after part. You can have some variables defined globally or per job, or get it from the user. The extending is, we saw it in one of the examples that uh, basically we have these jobs and they are all extended with these information. So you can reuse the script part. And we saw this earlier. Yeah. Yeah, so there is a Docker hub that we saw where you have the public Docker images. GitLab also have its own registry, so the Docker registry, so you can use that for your needs. Yeah, I guess. Oh, I didn't try this one. Apparently, I have this, so it can how to run on Windows. I haven't tried it recently, and these slides were created. Uh, just a second. Oh, well, these slides were created a couple of years ago, and I updated only the first few part of the slides and then wrote those examples. So I'm not sure about this. Apparently, this is old because since then macOS is available. Yeah, these are some questions. Anyway, let's go back to here, and that's it. I think I'm way past what I planned. Any questions before I finish the video? Well, I can smile at you like this. Any questions? I guess everyone or either fell asleep already or ran out of questions. I can now stop the video now, and then we can have some conversation if you like. For now, thank you very much for all the people who participated and remained here. Most of the people, apparently, we are like 18 now. We started out, I think, 22. And those people who are watching the video, please also you who watched live, later on go to the YouTube channel when I upload it and like the video and follow the channel and let other people know. That helps me get the word out, and it also encourages me to make more videos and more presentations. So thank you very much, and again, just like the video and follow the channel. Thank you very much, and bye bye.